What's going on, everybody? Welcome to the Blackboard. In this video, we're going to continue on with the characteristic equation lecture. The only difference is we're going to plug in initial conditions so we can find what our C1 and C2 is. And this is relatively simple. I mean, the first part we've done it before. It's just this new part. It's just pretty much plug and chug. So let's actually get started. So this first example, we're told to find the particular solution to y double prime minus 4y prime plus 3y is equal to 0. Now, because this is a homogeneous equation with constant coefficients, we can go ahead and use the characteristic equation. And so after pretty much a long time, you can pretty much see what the characteristic equation is. It's the same thing as you see written on the ODE, except for the y's, it's just r's. And that is equal to 0. And so we can factor this out to r minus 3, r plus 1, I believe. No, not plus 1, minus 1 is equal to 0. So we have r is equal to 1 and 3. So our equation or solution will be y t is equal to c1 e to the t plus c2 e to the 3t. And so this is now the part where our particular solution comes in. So like I said, it's just pretty much plug and chug. So when y is equal to 0, then we know that e to the t and e to 3t, which would be 1. So that would just be c1 plus c2 is equal to 7. And then we have our y prime of 0. That would just be the derivative of e to the t is just e to the t. So when plugging that to e equals 0, we have c1 plus, and then e to 3t, that would just be 3 e to 3t, so this would be 3 c2, and that's equal to 11. So now we have two equations, two unknowns, and we can just use whatever methods to solve them. For me personally, I will just use the matrix, and then just do row reduction. 7, 11, and then this will reduce to 1, 1, 0, 2. This would be 7. 11 minus 7 will be 4. So this tells us that not C2, 2C2 is equal to 4. So that means C2 is equal to 2, making C1 equaling to 1 plus, no, C1 plus 2 is equal to 7, so C1 will be 5. Thus, our solution will be C1 is 5, so 5 e to the t plus 2 c, not c2, e to the 3t. And that's pretty much it in terms of solving them. So we can go ahead and do the rest of them, which shouldn't take that long. So for this one, characteristic equation, not r squared, 9r squared plus 6r plus 4 is equal to 0. I can't think of a way to factor this out, especially with this 9. So I'm just go ahead and do the, what's that thing called? Quadratic equation. So this would be negative 6 plus or minus the square root of 36 minus 36 times 4. I'm just put 36 times 4 all over 2a. So this would be 2 times 9, 18. So this would be equaling 6 plus or minus, factor out the 36. So the square root of 36 would just be 6. Square root of 1 minus 4, so it would just be negative 3. So now we're going to have a complex solution. Again, this is going to be equal to 18. And so this will just pretty much be negative 6 over 18 is negative 1/3 plus or minus 1/3 times the square root of 3i. And so this will be the complex solution case, so this would be our A, this would be our B. So our general solution, which is b y of t, is equaling c1 e to the negative t over 3 sine of root 3 over 3t plus c2 not cosine. We're going to do e to negative t over 3 cosine. There we go. Root 3 over 3t. And so now to plug in our conditions. So y is 0. That means sine of 0, which would be 0, giving us c2 equaling to cosine of 0 is 1, 1 equaling to 3. And then y prime. That is the annoying part, mostly because when we take derivative, we will have a product rule condition or scenario. So this would be c1 times negative 1/3 e to the negative t over 3 sine of root 3 over 3t plus c1 e to the negative t over 3 times cosine root 3 over 3t times root 3 over 3. And then this will be minus c2, well, c2 is already 3, so it'll be 3 times negative 1/3, so it'll be 1, should be e to negative t times 3 cosine of root 3 over 3t minus 3e to the negative t over 3 sine of root 3 over 3t times root 3 over 3. And so now when we plug in y prime is equal to 0, we will get, this will go away, the signs will go away, leaving us with c1 times root 3 over 3 minus 1 equaling to 4, or root 3 over 3 c1 is equal to 5, making c1 equaling to 15 over root 3, or 5 root 3 over 3, I believe. Yes. And that makes our solution being, oh no, this goes away because I divided it. So it should be 5 root 3. 5 root 3. So our solution ends up being 5 root 3 times, this was the cosine, so not that, e to the negative t over 3 times cosine of root 3 over 3t plus 3 e to the negative t over 3 sine of root 3 over 3t. I'll stop it here for this video. There will be part 2 of this one, and so I'll see you in the next part.